Okay, we're going to start talking about parallel processing or distributed processing, and this is not something that most people ever actually see or use themselves because this is typically restricted to jobs that are very, very large, complicated jobs that are outside the range of a personal user on their computer by themselves, but large jobs. And here's a very common, here's a very uh, well-used example of distributed processing or parallel processing, and that's in the film industry. When they make movies, specifically movies that are high on computer graphics. Um, I'll use one movie because I watched a documentary that kind of demonstrated some of the computer processes. But if you remember the old movies, Lord of the Rings, a lot of CGI went into those. They built an entire, they call them a farm because it kind of resembles, long rows and rows of computers, but basically a computing farm with hundreds and hundreds of computers. And what they did is each frame of a film could be sent to one of those computers, while another frame of the movie was sent to another to be rendered. So I have here a program, and so let me kind of demonstrate this on a program I have. This is not nearly as sophisticated as anything you would ever see with a full Hollywood movie, but this is called, let me cancel the screen here. Okay, let me close that too. Trying to get all these little windows out of the way. Okay, let's see if we can. I may have to start this video over because it's my program is not wanting to open. There we go. Okay, this is a kind of a 3D world program. Very briefly here, you can kind of see I've started a little mountain here, and this is kind of a lot of times how designers work is they work on this wireframe because it's so um, the computer it would be too demanding for it to draw this scene other than in a wireframe. So I'm going to draw what's called a preview here. Let's see, let's set this quality to basically default, low quality, very small image, and let's just render this image out. And I don't know if you can tell what's going on. It's going to take multiple passes. Let's see, it's doing one more pass. And is there one more pass, I think, before it's done? That may be one more pass. And basically what each pass is providing more and more detail. Okay, it just finished. It took about 19 seconds, I believe it said there in the corner of the screen. Now, that was on low quality. Low resolution, not what people are wanting when they're making 4K movies and when these environments have so much detail to them. In fact, let me back up a little bit. It's a little close to this mountain here. So maybe we'll see more of the sky this time. Now, I'm going to run it one more time, and I'm going to change the quality to premium. And let's run this, and I want to see if you can see the timer going down here. That's the first pass, second pass, starting the third pass. I'm not going to let this run because I believe this is the estimate of how much time it has left. That's about 9 minutes and 32 seconds for this one frame. Now, let's do a little math problem. If I wanted to make an animation where my camera flies over this mountain, let's say a 10-second animation. If there are, and generally in films, there's 24, 48 frames per second. Let's just say 24 to keep it simple. In 10 seconds, how many frames? Remember, videos are nothing more than pictures, one after the other very quickly. So how many frames would it have to render in order to make a 10-second flyover of this mountain? Well, 10 seconds, 24 per second, that's 240 frames. Now, if this takes an average of 10 minutes, that's a long time, just 240 minutes. Did I say that right? There's 240, no, 2,400 minutes just to render this scene out. I may have done the math wrong there, but you get the idea. It's hours to render this little 10-second. Now, let's say you're rendering something that's way more complex than this, that has reflections and different light effects, and you're making an entire movie, and you're making it 4K, and it would take about 3.5 months to render this scene out. The answer is to allow multiple computers to render the scene out. So what I'm going to do now is I'm going to stop it for a moment. I've created an animation, and as you can see here, let me go back to the timeline. I can scrub this timeline here, and as you can see, it's just kind of flying across the mountain here. Now, I have already rendered out, let's see if I can find my program here. I have rendered out earlier today at a low resolution, so it wouldn't take that long. The frames, and it took, let's see, I think mine was only like 6 seconds. I created 141 frames. Those are at low resolution. I was probably using the 22nd. And you can see, I'm going to try to shoot through this very quickly. I'm just going to play each frame. So this is kind of my movie. And again, this is low resolution, low quality, like 6 seconds. Now, let's say I wanted to do all that as the highest quality, 4K, I add all the lighting, change it to the highest quality settings. So this program, and the reason I'm using this program here is it actually features a program called Render Animation, and there's a network manager here. So if I click on here, and well, apparently I can't move this screen. It will not let me move the screen. So right down here says Render on Network. So let's see if we can maybe see half of it. And this allows me to add, I can install this program on as many computers as I want, all in the same network, add them all to this list, and when I hit go, it's going to send one frame to one computer, another frame to another. Now what you can't do is have two computers work on the same frame because it requires information from one computer before the other one can actually do its work. They kind of depend on each other. So, but in jobs like rendering movie frames, it's perfect for one frame to just work on one computer. And hopefully, if I can get this set up right, you will see, I'm going to record this in a future time, this process actually running in the computer lab where I'll maybe pick 4 or 5 computers and see if we can render this onto 4 or 5 different computers at the same time to, and again, it's a time saving, it's a cost saving, because remember, time is money, especially in certain industries. So this is all an example of the idea of distributed or parallel processing. Let me go back to my slides here. And how this again, I just use this example so you can kind of see some of the more advanced ways computers are working and scheduling their jobs is to actually use entire computers, entire servers to do this. Let's move on. Just some terms. This is very practical things because you'll see this in laptops and computers that you shop for. There's only going to be 2 CPUs manufacturers that you need to be familiar with. There's other microprocessors in very specialized fields, like maybe in a calculator, some phones. But for general purpose computing power, these are the only 2 CPU manufacturers. That's Intel and AMD. Intel, if you remember, was the company that first introduced this back in 1971. AMD, I don't have the exact time they were founded, but I know I've been using AMD chips since at least the early 90s. So close to 30 years, I know, or if not more, they've been around. So know these 2 names, Intel, AMD. I'm going to quickly pull up my task manager again real quick here. And let's look at, and let's see if we can find out, I don't think the task manager actually says what CPU is in this. So I'll tell you what I'm going to do. Instead, I'm going to open up another program called System. Again, you can type this on your computer. Just type the word System. And it says here, Intel Core i7 at 3.4 gigahertz. And we talked about by gigahertz and what that number meant in the last section. But this is an Intel CPU in this computer. I believe you have Intel CPUs at school as well in the computer lab that we purchased last year. But AMD is this is kind of like Coke and Pepsi, Ford and Chevy. Some people like Intel, some people like AMD. They both kind of like to bash on the other and say that they're the better processor. Generally, Intel has the name recognition. They're generally has a little higher end processor. AMD kind of gives you more bang for the buck. So it's almost as fast, about a third the price, or 2/3 the price for about almost the same performance. Excuse me. When you purchase a CPU, a couple things to know about. First is its speed. CPUs are measured in hertz, and they have now gotten up to the point where they're gigahertz. They started with megahertz, and then went to gigahertz, billion times per second. This one's 3.5. It used to be very easy throughout the 90s to know which CPU is faster by just that number. Unfortunately, things have gotten a little more complicated because for each cycle or each hertz, basically, for every hertz that it operates in, it can do more than one instruction now. It gets a little complicated the way they schedule it. I kind of glossed over a lot of the scheduling, but that's where there are other websites that basically they take a CPU, put it in their computer, take a job, let's say that same mountain rendering job, send it to the computer and time it. And then they do it for another processor. And they kind of report back a score or a time to kind of give you a relative performance. So let's, the website we use the most for comparing, let's pull up another web browser here, is called Passmark. There's many that do this, so this is just one that we like to use, called Passmark. They've been benchmarking since 1998. Generally what I'll do is, you can find, a CPU in here. Generally what I'll do is I'll just type my CPU in there. So this is my 4700. This is the same processor that I just showed you on that screen right here. Whoop, not that screen. Did I close it down? I may have closed it. Nope, right here. So that 4770, typed it wrong. I have a 4770, and I hit enter, and it just searches that for me. Okay, so again, let's say you're buying a computer, and it claims to have a such and such processor. Don't even listen to the salesperson. Don't even look at the numbers, 3.4. Go to a benchmarking software program or website. You can do this on your phone as well. And this one gets a score of 9778. What that number means doesn't really matter. That's just their score. So at least you can compare it. Now, let's compare it. So I purchased for the, I didn't purchase personally, the CPUs I selected for the computer lab last year when we upgraded. I would love to put the most expensive, fastest processors, but we had a little bit of a budget we had to constrain to, especially since we were buying 24 of these. We had to kind of think of the price times 24, and we went with what's called an i3 8100. So let's see how fast that is. So I type that in, and it comes up with a score of 8,033. So which one's faster? Well, my processor is a little bit faster. Again, just doing two processors doesn't really give you an idea of. In other words, it's a lot faster, but is that a big deal? Well, let's do one more. If you were to buy a brand new i9900, this is one of the more popular CPUs for people who can afford it. It's a 9900K. Let's see how fast it is. Now, one factor I'm not showing you on all this is cost in dollars. Sure, if you have no budget, you can buy the best. This is near the highest. Let's see what score this one gets. 20,000. So this one is at least twice as fast as my computer, and a little over twice as fast as the ones in the computer lab. So using that, you can kind of look at the price and try to figure out whether that's something you can justify and afford. So just a little practical tip when you're buying a laptop is find out exactly what processor it has in it, and then come here and get a score. Now, one thing I will mention, because this is important, is this is a score for all of its cores. Now, remember how I talked about the core? Let me put my graph from earlier. Let's see, do I still have that open? I don't think I have that open anymore. Here. Remember these 8 cores here? Well, if all 8 cores are in use, that's the score. And this one has 8 core. You can see it right there. However, they also show you a single core. If you just had a program that did not use all 8 cores effectively or at all, some games, for example, are never designed to use more than 2 core. So having 8 does not help you any. So it gives you the score if you only had 1 core or single core, and that gives a 2898. So some people put, about a 50-50 weight in which one is more important. Maybe taking, kind of both of these together. You'll have some that have a very high end here, but lower here. And this number is always going to be higher for processors that have 8 core. If we pull up the i3, the 8100 we just showed you a moment ago, that one, I think has 4 or 2. Has 4 core, so it has 8,000. This score dropped, but notice how that score dropped from 20,000 to 8,000, but the single thread didn't drop that much. It dropped a little bit. And that's because the actual speed of just one core, I hope this isn't all too confusing, but it confuses a lot of people out there, especially people who are buying computers, get all these numbers and they see 3.6 and they see 8100 and which one's faster. Generally, I would just use a website to kind of take both the single thread and the all the cores. This one has 4 core. You also have CPUs called Threadrippers. Threadripper. Let's try the 2990. I've not tried this, so I know this has a lot of cores. This processor has a score of 19,000, but it has 32 cores in it. So I would have thought that number would have been much higher, but some CPUs, I guess, don't operate as efficiently. So, but that has 32 cores in that CPU. So, that's a little bit about CPUs. Let me go back and see what I think there was something else I was going to mention before we move on here. So yeah, basically just checking on the core. If you're playing mostly games, if you're typing papers for English class, if you're doing Excel, you're not going to benefit from 4, 8, and 12 core. Those are for the jobs like video rendering, audio processing, even things like Photoshop and graphical things. Browsing the web and watching videos, and they're just not going to benefit. So if someone says, oh, you need to buy this 8 core, save your money. Unless you want to buy a laptop that does everything, and budget is not an issue, you can generally go with a quad or even a dual core and be just fine. So from this, I think that's the last thing I was going to mention. Yes, on CPUs is a couple things. Intel, AMD, the idea of the speed measured in hertz. Generally, I think one thing I also want the rest of the class to know is that general numbers are in the 2, 3, 4 to 5 gigahertz. So you'll never see a 28 gigahertz or a 92 gigahertz. Right now, almost all CPUs are operating at 3, 4, 5 gigahertz, kind of in that range. So I do want you to know kind of a scale. So if you do go shopping for a computer and it says 1.9, that's a little low. Of course, if you went to that website to look at the benchmark, that would report similar low values. Don't worry about the socket and the core. Just understand that CPUs now are coming with more than one core, which is basically like a miniature CPU. It's not an entire CPU, but a miniature CPU, so that it can, let me get back here, perform multiprocessing. You cannot do more than one thing unless you have, at the same exact time, unless you have 2 processors or 2 or more cores. So know the speeds, know the names of the companies, and know that it's basically performing all the calculations in your computer, and kind of how to gauge the speed and its performance. Like I showed you a moment ago, just to return real quickly back to this graph, and more importantly, this processes is, how much work is my computer doing right now? Well, mine is only 40, bouncing between 20 and 23%. I'm actually recording a video right now. It tells you that computers can do a lot with not a very powerful CPU. So you don't have to feel pressed to buy the most expensive CPU. If you're doing average things, get an average CPU with just an average speed, average core, average benchmark speed, and you'll do just fine.